Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
All right, so I want to talk to y'all about a software project that I've been involved with called Total Impact. I'm going to be presenting off this Google Doc, and so I encourage folks to, I was kind of hoping the screen size would be a little bigger and we could see the chat window, but it doesn't look like that's going to happen. But you can write, if you have questions or whatever as I'm going, write the questions down at the bottom. The Google Doc is, this is the bit.ly link if you want to go to it, and I also just tweeted it. Oh, okay, yeah, good call. Thanks. We'll see if I can get that. There we go. All right, well, there's tiny pieces of it fitting in there. All right, apologies. Anytime I'm trying something new, always goes awkward. So Total Impact is designed to get a bunch of different evidence of impact from a bunch of different sources, and I've managed to kill 2 of my minutes on that. Anyways, it's supposed to get, thanks. It's supposed to get various types of impact for various different types of scholarly product. And I think the name is a good one. Paul Gross came up with the name. And the nice thing about a name like Total Impact is you have all kinds of possibilities for logos. So I figured it'd sound kind of like maybe a series of exercise videos for mixed martial artists or something like that. But we ended up going with Dario's very, very ably designed logo, I think it said. So the general idea is that our current picture of scholarly communication is kind of like looking through a keyhole. We only get a very narrow sort of segment of the different parts of the scholarly communication ecosystem. To maybe shift metaphors a little bit, I kind of think of it as scholarly ecosystem being this vast rocky plain where we've got all these people going to and fro and they come up with all these good ideas and everything. And we want to try and track these ideas, and so we've had people do it very intentionally so far. We've said, look, leave a pebble every time you go somewhere, right? And those are the citations, and they do it on purpose, and that way we can track things. But now, with the web, these activities that scholars do are increasingly happening over, instead of a rocky plain, sort of a rocky plain with a fresh fallen snow on it. So then when people go to and from and they share their ideas to this place and that place, they start leaving footprints unintentionally. And that can be a much, much richer set of data, as you can imagine. I think this matters. I think it's worthwhile for us to try and get more sources of scholarly impact because we can do it more quickly on the web, which is, I think, good for evaluation purposes, good for trying to find out where the current research is going. We can reward what should be rewarded, and that's purposely sort of a value-laden statement, right? I mean, I think if we assume that scholarship is about more than publishing peer-reviewed articles, which we don't all, but I think is, for me, a safe assumption, we should start trying to reward those things other than sharing peer-reviewed articles. So, for instance, public outreach, sharing data sets, writing code, all these other sorts of activities. But we can't reward that unless we actually have the evidence of it. And we can also start to track impact outside the academy, right? Because people who use research articles often are not people who write research articles, right? They're clinicians. They're people who don't go on to cite it. And so this is, I think, a good way, by looking at web impact, for us to get this stuff. So I'm talking for a while. Let's actually look at the site. Looks a little cramped on this small window. Again, I apologize a little for that. But the idea behind Total Impact is that you create a collection of research objects. And those can be any kind of research object, pretty much. Right now, we can list them by URL. You can list them by Mendeley ID number. You can list them by DOI. You can list them by PubMed ID. I think we have a couple other identifiers that you can use. So we fill in this box. And I encourage you to check out the site on your own machine if you want to maybe get a better view of it. So we fill in this box. Let's imagine, to kind of walk through it, let's imagine a scenario. Let's say I'm a grant organization. I've funded a bunch of research. And I want to find out the impacts of this research. So what I might do is I might go over here and fill in my PubMed grant number. And this is just a pre-filled in, but obviously you'd fill in your own. I hit import, and then I fill in all these IDs that are associated with the grant. It goes in and gets those from PubMed. I'm going to actually, for the purposes of this demo, I think I'll use a restricted set of these because it can take a little time to gather the data sometimes. So here's my grandiest, but let's say I want to add some more stuff. Let's say I also want to add Dryad data sets. So I put in the person's name who's listed as the author. Again, it goes to Dryad, finds that, and now it's added these Dryad URLs to my collection. I could also use a Mendeley group. So a lot of grant organizations, right, they keep sort of a list of everything that they've funded. If they keep that in Mendeley, it's just one click, right, to import that out. And I can do some other kind of cool stuff that Cameron apparently is helping with, even though he doesn't know. He's our example person, right? So I can import Cameron's publication. I could also look at all of his contacts. This one is a little dodgy, how fast it works sometimes. But if it works, it'll actually, yeah, there we go. It'll show me all of his contacts, and I can just click on one of these contacts, and it'll take me directly to their report. So the idea behind this is, even though you can manually enter this, it takes some time, and people may not have those lists. So we're trying to make it as easy as possible to populate with those with one click. But we think it's very important that this process, the populating process, is distinct from the aggregating process. What we're measuring is activity on artifacts. You can aggregate that at the level of the person, at the level of the institution, at the level of the country, at the level of the journal. Any different sort of aggregation level that you want, you can fill in here. So we've got our sample. Let's go ahead and run that. And this takes a little bit of time. And while it's cooking, I think I will go ahead and look at a sample collection. So again, apologies, it's a little bit tough to see right now. This is one that we just sort of made, just kind of showed off. So we start out with a list of articles. And then we have slides, we have data sets, and we have unknown, which is generally URLs, and we have software. Because again, we feel like all of these are research projects that are worth measuring. And the software figures out what things you've entered on its own. So looking at articles, some articles don't have a lot of activity, so we've got PubMed citations there, and we've got bookmarks there. Other articles have a lot of activity. So this famous PLOS article about Falacia by fruit bats, right, got a huge amount of popular buzz about it. So unsurprisingly, we've got a huge amount of metrics. All these different, we got a lot of Facebook, we got vast amounts of page views. In cases where we have extra data, like in the case of PLOS, which has done a great job with their ALM, we gather that. In cases where it isn't, so I don't even know what molecular biology and evolution, we don't have as big a set of data, although we can still go ahead and look at SiteUlike in places like that. So we look at SiteUlike, we look at Mendeley. There's a list of all it's too many to really go over, of all of the sources that we crawl on the site. I think Wikipedia is kind of an interesting one. Notice that I don't have to take the system's word for this. I can go ahead and zoom in and look at the actual Wikipedia search results and say, oh, okay, interesting. So this article is cited in this this Wikipedia article on metagenomics, something like that. So for any of these metrics, I can actually zoom in and look at the qualitative data as well. That's particularly helpful for, let me find with tweets. Yeah, for tweets, right? So I can zoom in and actually read the tweets, which I think is pretty handy. For data sets, we look at the repositories. Right now we have Dryad a lot, and we can look at page views and things like that. For these unknown ones, I think these are kind of handy, right? So this is a blog post. So for science bloggers, they can look in and they can see their activity on Twitter and Facebook, and from other blogs, because we look at research blogging as well. None of these happen to have any. For something like this, right, where you have the program, it's not a website, but it's something that happened on the web, we can look at the buzz for that. I think software is pretty important. People are talking about it a lot, so we look at both GitHub and SourceForge to look at how many people are following a particular piece of software. So for instance, something like R. Mendeley, it's difficult to cite in a scholarly publication, but we can look at these things and say, oh yeah, this is some kind of evidence of impact. So I'm going to go back to our other. So this one, as you can see, like, not particularly large data set, but this is the one that we just entered a minute ago. And it takes like, I don't know, like 30 seconds or something. The nice thing about this is I can always go back there. It's got a permalink and it stays there. And so I can watch over time as these metrics sort of hopefully pile up, right? I can also do things like download the CSV. With the CSV, I can go ahead and put it into other platforms. So for instance, if I wanted to make my own visualization, like I did this for a poster. So this is a heat map of all the different metrics and all their different values. There's also a JSON API, which I'm running short on time, so I won't show you. Everything that you see comes through the API. So, and we actually use the API to populate the data. So that's completely open and anyone can input stuff or export stuff at the API. That's really important because we want this to be scalable. We want it to, you do not have to go to this, right? Because this is my wacky little visualization that I hacked up like last night, right? Instead, we want you to be able to build your own applications based on this. Consequently, it's important to us that we build it to scale. So it works at, as I said, multiple aggregation levels. It's a CouchDB database, which is hosted in the cloud, and it can scale to many, many millions of records. Runs on a cloud server. Any new plugin that you write, so every particular kind of metric that we gather, the plugin can actually be located on any server in the world because it communicates over REST. So it's very easy. Plugins can be written in any language, and they can reside anywhere. So most of the bases in PHP, a lot of the plugins are in Python. You can write a plugin in, you know, Haskell or whatever thing that you want to write in, and it can still work with this. All of the metrics that you see demonstrated here are they're legal, right? I mean, they're not. We're not crawling anybody's page and then we didn't tell them about it or something like that. So it's important to us to try and make this reusable to people, and so that was one of the things we wanted to look to emphasize. It's open source on GitHub. We've got a lot of people who say, oh, you know, we want to modify this, and they do. Limitations that we don't know exactly the numbers mean yet. We're looking for future research for that, and they tend to be a little subject specific. One of the big things that we want to do in the future is actually try and get you know, funding to actually hire people to do this full time. Everything you see here has just been me, mostly me and Heather Pavovar, and then also a large other group of people who've contributed other things as well, sort of working on our own time. And I think it's really exciting to see that this much can be done just with some people goofing around on their own time. I think, imagine doing something like this like Eugene Garfield when he started the ISI, right? He had a lot of seed funding to do that because it was a really complicated thing. It was a lot of shuffling paper around. This kind of work, the great thing about it is it can be done comparatively very cheaply and very easily. And I think with a you know, moderate amount of funding, I think there's a lot of potential for this to be maybe the next ISI, but done in a more open and a more available way for people. And that's it. Thanks.